So next up, we have Tim. Tim, I'm going to add you to the stream now. Tim is from JetStack and is going to be is a cert manager maintainer. And this talk is generating and distributing trusted certificates using Cert Manager and Trust Manager.
And there's already been a lot of Cert Manager questions, Tim. I'm sure you saw those. We punted a few for your talk from the last two talks. So keep those Cert Manager questions coming for Tim. And thanks for joining us, Tim.
All right, so we're going to remove ourselves and add your slides.
Thank you. Yeah, very interesting last question. I think that will be a question that I'll try to respond to in this talk. So very cool. All right, so I'll be presenting how to generate and distribute trusted certificates using Cert Manager and Trust Manager. So I'll be explaining the Cert Manager and Trust Manager components in our Zero Trust setup. But first, let's talk about Cert Manager. Cert Manager is a project. It's not just a product, it's a project. So in this project, we have a lot of contributors. We have a bunch of core contributors, but also a lot of external contributors, more than 400 contributors. And there are two main products in the Cert Manager project, namely the Cert Manager product and the Trust Manager product. And then we also have a bunch of additional add-ons on Cert Manager to extend its capabilities. The main purpose of Cert Manager is basically to do X509 certificate management for Kubernetes and OpenShift. And we do that through a bunch of operators, Kubernetes API extensions, and on top of that, a lot of add-ons that can interact with this Cert Manager installation. Cert Manager itself was created by JetStack, the company that I work for, but it has been donated to the CNCF Foundation in 2022. And in the meanwhile, it has already reached the incubating status there. And that's, of course, because it's used a lot. So I think most of you running a Kubernetes cluster will also have Cert Manager installed, which is, of course, very cool. But it also shows that Cert Manager is a very necessary product. And to kind of summarize it, the main benefit of Cert Manager, I would say that Cert Manager automates all this certificate stuff so that your application can focus on the business logic instead of just managing these certificates, because that's something that often you don't want to think about, right? You don't want to think about these certificates, so we automate that for you. And then in the context of this Zero Trust Day, it's a bit contradictory because I'll be talking a lot about trust, and the Zero Trust Day is, of course, called Zero Trust. But what we actually mean with Zero Trust is that we make zero assumptions about trust. And what does that actually mean? Well, I'll give you an example here. I'll give the example of logging into your banking application. Now, if you're talking about banking, I assume that you don't want to make any assumptions about trust, right? So how does this work? How does the normal flow work when you connect to your banking app? Well, first you set up a connection to mybanking.com or mybank.com, and then this server responds with a proof that the server that you're talking with is actually part of the same company that owns the domain name mybank.com. And it does that through a certificate that it presents to you. After you receive that certificate and you do some additional setup, this TLS handshake is completed, and now you have a fully encrypted connection where you can trust that the other party in the connection is actually the party mybank.com. And then you can also, because you trust that connection, you can, for example, send over your login credentials over this connection. That way, mybank.com can also start to trust you, because now you have given mybank.com username and password, for example. I know that most banks should use like two-factor authentication on top of this, but this is a simple example. So username and password. And after you provided username and password, the bank can start trusting you. So it's clear that in this example, there are 0 assumptions made about trust, right? However, there are some initial things that you have to trust in order to get this set up. For example, I have to trust that mybank.com is actually the domain name that's used by my bank. So there's a difference between the domain name and the institution or the company, my bank, right? And this link has to be there, and it has to be correct. If you go to mybank.io, it could be another company or another individual that's hosting that website. Also, you have to be able to verify that the certificate that mybank.com provides to you is actually a valid certificate. That's something I'll go into later in the presentation. And then, of course, the bank has to trust the username and password that you provide to the bank. And this is a fairly basic example. I think most of you use this every day, right? However, you can also apply these zero trust principles to communication between two servers. And this is where this MTLS becomes very interesting. And that's also where Linkerd, of course, is a very interesting component. So the idea of MTLS is that you have mutual TLS, which means that both parties actually provide a certificate to prove that they are who they say they are. So for example, if server1.mybank.com communicates with server2.mybank.com, it presents a certificate that contains its identity server1.mybank.com. And then server2 can respond with its own certificate. After that, after the handshake, you can send data encrypted, and you know that you are talking with the party that you want to talk with. And you can also limit the information that you send over this channel to the information that is only that should only be seen by this other party. And so here MTLS is a very powerful tool. However, often it's not used, right? Often in a network, you make trust assumptions. You say, okay, in my network, there are no bad actors, so I'll just send everything unencrypted. And then you get into a non-zero trust situation, of course. So also in this setup, you need to be able to verify the certificate, and you have to trust these identities. And that's the question that we will try to answer next. How do we actually set this up, right? So we have two challenges that we have to overcome. First, the application needs a certificate. And that certificate has to be trusted by all its clients. Then also the client needs to be able to trust the certificate of the application. So it's a two-way problem, right? And to solve this problem, we introduce a third party. So next to the client and the server, we also have the certificate authority. And this party is only important to set up everything. After the setup, the client can communicate directly with the server and can trust the server directly. However, for the setup, we need a certificate authority. And so what does this certificate authority do? Well, it provides the client with its own certificate, so the certificate authority certificate. And by providing the client with a certificate, the client can now trust all the certificates that the certificate authority has ever issued or will issue in the future. Additionally, it lets the server issue certificates, and the server can then use this certificate to prove its identity. Additional to the certificate that proves its identity, it also provides the server with a whole chain, starting from the CA certificate up until the certificate containing the identity, that can then be used by the server to present to the client so that it can prove that it is, so it can be used as a proof. And so that way, the certificate authority is not necessary anymore. You can just communicate directly between the client and the server. And so for these two steps, with the Cert Manager project, we have created two products, namely Cert Manager and Trust Manager. And these products actually automate these two steps in the cloud native environment, Kubernetes. So for example, with Trust Manager, we automate this CA cert distribution. And then with Cert Manager, we automate this issuance of certificates. So in this demo, we have two instances where we will be using Cert Manager. The first instance is to issue emissary certificates. And these have to be certificates that are trusted by public CA. So public CA are basically the CAs that are trusted by all the web browsers, let's say. So for example, the Mozilla Trust Bundle is the Trust Bundle used by a lot of web browsers, but also by like all the Linux distributions when you install CA certificates. And that contains a bunch of these public CA certificates. And by trusting all these public CA certificates, you basically start to trust a lot of domain names, or all the domain names, let's say, all the public ones. And you get into this public trust domain. So we need to get in there, right? And a great tool for that is Let's Encrypt. Because with Let's Encrypt, it's easy and it's free to do this. Free as in you don't have to pay for it. So this is something that we automate with Cert Manager. And we basically have this issuer integration for Let's Encrypt, this Acme issuer integration. And it lets you create a certificate and its private key and puts those two items in a secret so that it is accessible by your Kubernetes applications. Additionally, you can then use Trust Manager to distribute all these public CAs to all your applications, so that there in your application you have an up-to-date version of your public CAs. Then the second example that we use in the demo is an example where we are not talking about public trust, but we are talking about a private PKI. So in this example, we are using Vault, and in Vault we have stored the CA certificate. And then we use Vault to issue an intermediate certificate. And this is also done through Cert Manager. So we have this integration with Cert Manager where we basically create an intermediate certificate, store it in a secret, and we sign this intermediate certificate with Vault. And then we basically, or I at least point Linkerd to this secret, and Linkerd can then create all these MTLS certificates, and it does that automatically. So that's all automated by Linkerd. Also, the distribution of trust is also automated by Linkerd. So there's a bit of overlap here with the functionality of Trust Manager. So Linkerd also distributes this trust. So let's now look into more detail how the issuance flow of Cert Manager actually works. So we fully automate this issuance flow. And this issuance flow exists out of 4 steps. So first, a certificate is requested. So this can be done, for example, with a certificate custom resource. And you create this custom resource and you point it to a location where you want the secret to live. This will be the secret where, in the last step, the certificate will be provisioned together with the private key of the certificate. Also, in this certificate resource, you provide some details that you want to exist in the certificate itself. So after the certificate is created, a certificate request resource is created, and this certificate request resource goes through this whole process. So first, there is policy evaluation, where a decision is made on whether this the certificate request should be accepted or not. If it is not accepted, here the issuance flow stops. If it is accepted, it goes to the certificate issuance step. Here, it's actually the integration with the issuer that is working. So for example, in the Acme case, you connect to Let's Encrypt, and you let Let's Encrypt sign the certificate request. Or you could connect with Vault, for example, and let Vault sign the certificate request. And then with the signed certificates, you go to the next step, where you provision the certificates in a secret, for example, but we also have plugins to let you provision it in the file system of a container, so that it is accessible by the application that will ultimately have to serve the certificate. And so here we see the components that map to these 4 steps. So generally there are only 3 components, because the request and provisioning is kind of combined in these components. So the first 2 options for requesting and provisioning are Kubernetes ingress resources and Kubernetes secret resources. An ingress resource you can add annotations on. That will be detected by Cert Manager. And then based on that, a certificate resource will be created. For Kubernetes secrets, you actually have to manually create this Kubernetes certificate. And then the flow begins. I'll show that in more detail very soon. Then with our Kubernetes CSI driver, you can specify in the configuration of the pod what kind of secret, or what kind of certificate you want. And based on that, a certificate request is created directly. And then the private key and the certificate are stored directly in the file system of the pod, without the private key ever coming in the cluster state. So that is actually a more secure solution. And then we also have a lot of integrations with service meshes. So that's for requesting and provisioning certificates. Then policy evaluation. We have this approval policy plugin that lets you make decisions on whether you want to approve or deny a certificate request. In our demo, we won't be using that just for simplicity's sake. And then you have these issuer integrations. And here there are really a lot of integrations possible. We have Acme, which is used by, for example, Let's Encrypt. Then we have Vault, which we will also use in our demo. We have also Venafi, which is the parent company of Jetstack, actually. And then we have a bunch of external issuers, which are basically additional controls that you can install in your Kubernetes cluster and that Cert Manager integrates with. So this is the same flow, but in more detail. So you start with creating a certificate resource. Then Cert Manager will create a certificate request resource based on the certificate resource. And that is then linked to an issuer or a cluster issuer, which contains the configuration on how to issue a certificate. For example, it contains the credentials of your Vault instance. So Cert Manager uses this configuration to sign the certificate request, and then puts the signed certificate together with the private key in a Kubernetes secret. This secret then contains the private key, this signed certificate, but also the whole chain, starting from your CA up until the leaf certificate. Also, this secret will contain a best guess at what your CA certificate might be. And so the last thing I want to explain to you is how Trust Manager works. this is an easy visualization of what Trust Manager does. And in principle, it's very simple. You have a bunch of sources, and then you have a bunch of targets. And these sources are all your locations where you want to get these certificates from, these CA certificates that you want to trust. So, for example, that could be a config map, a secret, or an inline certificate. Recently, in version 0.4, we also added support for these public CA bundles. So, like I said before, this Mozilla public CA bundle, we actually download that and we put it in an image that you can install separately from Trust Manager so that you can upgrade these public CAs even while you keep the Trust Manager version at the same version. So this is really meant so that you can easily upgrade these public CAs. And that's very important because if there ever is like a problem with this Mozilla bundle and one of the CAs has to be removed from it, you as a developer, if you don't have Trust Manager, you would have to rebuild all these Docker images that you have in your application or in your whole cluster, basically. You would have to redeploy all these Docker images. So that could take a long time. What we provide with Trust Manager is an easy solution where all these trusted certificates are centralized. And if you make a change there, then they can be very quickly propagated into all the locations where you need these trust bundles. And honestly, that will be just all your pods, all your containers, because most of your containers will have to set up a TLS connection. So the targets are config maps. These config maps can live across multiple namespaces in your cluster. And then you can manually mount these config maps into your pod in a location so that it is added to your trust store of the pod. So in the demo, we will be using this new feature, this public CA certificates feature. And we will be mounting this bundle in a pod, in a container. And then we will be using that container to query our public endpoint and see that actually, yes, when we request, or when we set up a connection to this public endpoint, there are no TLS connection failures. It works perfectly. And so, yeah, that's what I'll show now in this demo. This is the cluster that you probably have seen before in the other presentations. Let me first start with showing you all the certificate resources that we have set up. So the first certificate here is a certificate that's used by our Vault instance. So we are actually running Vault in cluster here. And this certificate is a self-signed certificate that's used by Cert Manager to communicate with Vault. So it's more of a, it's not that interesting actually of a certificate. The same is true for this last certificate, which is a certificate used by Trust Manager. So it's also used by internal infrastructure, let's say. But these two certificates are actually very interesting. So those are the two certificates that I've been talking about in the presentation. So the first certificate is actually the certificate that's used for the public endpoints. So let me show you in more detail what that certificate looks like. So you see, it's a certificate resource, and
Tim, can I interrupt you for 1 second and see if you could
Yes.
zoom in a little bit? We have
Oh, sorry.
few people asking. There we go. Thank you. Sorry to interrupt the flow, but want to make sure everybody sees your special stuff.
Okay, great. How much time do I have, by the way, still?
Sorry.
We started you a little bit late, so you can run a tiny bit over. So
7,
technically 10 minutes. Let's just say 10 minutes.
Okay, great.
Okay.
So basically, what you can see here in the specifications are the certificate details that we requested, right? So the DNS name. For DNS name, we requested kubecrash.demo and so on. This is because this is the domain name at which we actually serve our demo application. So this is the public certificate that's used here. Let me see if I can actually show you these details. You can see here also that it's signed by Let's Encrypt. So that's also very interesting. And that's what is configured here, basically. So we have this issuer reference, which is a cluster issuer, and is the Let's Encrypt production, has the name Let's Encrypt production, and that's the cluster issuer that basically is configured to solve this HTTP O0 challenge to obtain a certificate from Let's Encrypt. I hope that I can show you this cluster issuer without revealing too many secrets. Here you can see that we actually connect to the Let's Encrypt endpoints, and we use HTTP O0 to prove that we actually own the domain name, because that's what Let's Encrypt cares about. Let's Encrypt wants to know that it issues a certificate to the person who owns the domain name. So let me go back to the certificates details. And then it also, here you also see that we have a reference to a secret. And this is a secret in which we will actually have the private key and the certificate itself. What's the namespace here? So I'll just show you. I hope that this is just the demo certificate. So try to serve your own web application. So here in this certificate, you can see that we have the tls.crt file, which is basically the leaf certificates combined with this chain, that the web server needs to prove to the client that it's actually a valid certificate, a certificate that the client can trust. And then we also have the private key here, tls.key. I don't see a ca.crt file, so that must be something that Cert Manager wasn't able to decipher what the ca.crt file is. But we know, of course, that it's just like the CA certificate of Let's Encrypt, and that we can just trust the whole all the public CAs. So that's the first certificate. Then the second certificate is very similar. Let me do this. So it's just Linkerd. So in here we see that we have a reference this time to the Vault cluster issuer, which contains the details on how to connect to Vault. And we also have some more interesting details here, namely, is CA true? And then these usages. And we basically need this because this certificate is not just a certificate I use for your web server. This is a certificate as an intermediate certificate. So this certificate itself also has to be able to issue certificates, because Linkerd actually uses this certificate to issue these MTLS certificates. And so basically, to show you, well, I showed you in the presentation the flow here. So these certificate requests resource you can also see. These are created automatically. And they are automatically by Cert Manager for a certain certificate. So for example, here you have the one for Linkerd. And if that certificate request is issued correctly, then there it ends, and Cert Manager just takes the signed certificate from the certificate request and puts it in the certificate itself. However, if there are failures or if there is a renewal necessary, then Cert Manager will create a new certificate request here. So if you see a bunch of certificate requests, either it's like a very long-running cluster, but then you might want to look into ways to automatically remove these old certificate requests, or there is something wrong and there is a failure, and that causes maybe Cert Manager to create a lot of certificate requests because it's retrying. So you can see both for Linkerd and the emissary certificate that we have these certificate requests. I can actually also show you that this request contains then the results in its status, like the final signed certificate. That's this basically, so the certificate here apparently also contains CA. And this is the request, yeah, okay, so this is actually the status, which is populated by the issuer integration. So I think this one is for Vault. So this is the Vault integration that has created this status or set a status value. Okay, I hope all that was clear. Maybe I'll also show you how Trust Manager is set up. So we have one Trust Manager bundle, and it's called Public CA bundle. This is a non-namespaced resource. In this bundle, I configured the source to be the use default CA source, which is the default bundle that is included with Trust Manager, and that contains all these public CAs. And then in the targets, you see that I set this config map, and I limited the namespaces to just the faces namespace. But often here you will just have an empty selector so that you create these config maps in all your namespaces so that applications running in all these namespaces can use these config maps. And so if you now look at this faces namespace, we see that we indeed have this public CA bundle config map. In that config map, we have this very long set of public CAs. And then we can actually mount this config map in one of our pods. So here we have this test public endpoint pod. And in here, I configured a simple curl command that uses this CA bundle to connect to our public endpoint. and it could just curls this endpoint. And if you look at the logs, you will see that it actually doesn't show you any failures. That means that the TLS connection is successful. So it has been doing this for a long time already. And yeah, great. So I think that concludes the demo. I would like to see if there are any questions that I can answer.
All right. Yeah, it looks like we have time for a few. Should we start with? Yes.
So we've starred one. Is there any service that we can introduce for chaos and fault tolerance test for the Cert Manager and Trust Manager?
The service, well, I think what would be interesting for you to know is what happens if, for example, an issuer configuration gets out of date, and what is the effects of that on your deployments? Are you able to notice this, and how soon are you able to notice this? Because with Cert Manager, it's quite complex often. You change the configuration, but the certificate is not renewed directly, of course. It's only renewed when it's necessary to renew the certificate. So maybe a configuration change that you make right now can fail 2 months in the future. So those are the scenarios that you really have to take into account. An important metric there is how far is a certificate from its renewal date, right? So if it comes too close to its renewal date, you know there is a problem. And then that's the kind of metrics that you want to monitor for. That's are the kind of metrics that you probably want to make sure that you're monitoring for. So if you're chaos testing, I think that's very important there. With Trust Manager, it's more about trusting the right certificates, which is also very complex, because when you rotate certificates, you have to make sure that you still trust the old certificates, let's say. So, for example, if your web server goes from one certificate to another, you want to make sure that all your clients still trust the old certificate, because otherwise, if the web server is still on the old version, they might start getting errors. So you have to, at some point, you have to basically trust both the old and the new routes. And then once you're fully switched with all your applications to the new route, you can also start changing all the clients. I hope that makes sense.
And speaking of testing, since you brought that up, what is the best way to test or debug this?
I think that one might have come up when we're running into issues in the demo. Yeah, maybe.
Oh, did you cover that one? I
think so.
Well, I think it's important to, what is interesting is, of course, the status of your certificate resource. So can I show the presentation again? Yes, great. So the certificate resource will have a status, and that status will basically reveal what's going on. But often you will have to go look at the certificate request status, or even at the, I think it's a challenge and an order and the Acme integration. So it's very important that you look at the status of these resources. They will reveal a lot of about what's happening with your cluster and why things are not succeeding. And of course, the events on these resources are also very interesting. I'll just see if I can get, So here in the status, you have this condition, right? Here it just shows ready because nothing has gone wrong. But if there is a failure, here in the message, it will give you a lot more information about what is actually going wrong. So you don't have to look at the logs of the controller most of the time, you can just look at this status and debug from here.
Can you use Let's Encrypt in a production cluster? This question just came in.
Yes, I think so. I think it's often used. Kind of depends on what kind of certificate you want in your on your website, right? So let me just get the. Let's see if I still have the demo somewhere. Here, if you look at a demo and you look at the certificate, you'll see that the certificate is signed by Let's Encrypt. So basically, it's all about your image as a company, right? If you think that this is not good for your image, Let's Encrypt, because it's a free service, then you might want to use other services. I think that's the main thing that you have to consider when you're using Let's Encrypt versus all other services. But also take into account that with Let's Encrypt and with their integrations, you might bump into these. So if you have a lot of errors and you send a lot of requests to Let's Encrypt, that might trigger some kind of limitation in Let's Encrypt where they say, okay, you can only send us X amount of requests every month, for example. And that's a real big problem for you, because after you reach that limitation, there's no way anymore to obtain a certificate. So my advice for you is to first use the staging environment of Let's Encrypt before you fully commit to configuration. After you have found a configuration that works for you, that doesn't give you any errors, then go to the non-staging environment of Let's Encrypt.
Okay. We're running, so there's so many more questions for you. So maybe you can jump in the chat and grab those. Amruja has another question. Sorry for all the questions we didn't get to, but Tim, can you hang out in the chat and make sure that you covered all of them? That would be awesome. Yeah. So I want to make sure we get to our next awesome presenter.
All right.
So
thank you, Tim.
Thanks.